Friends, welcome to the lecture in module 2, lecture 7. In this lecture, we will discuss about damage identification using lumped mass model. We already saw in the last lecture change in eigen values can enable damage detection. Let us now consider the dynamic equilibrium of forces acting at the jth story by considering all the story above jth story. We get k I j d I j of t plus c I j d dot I j of t is equal to f I j of t. Let us say equation 1, where k I j and c I j are stiffness and damping parameters of the jth story. F I j of t is the inertia force acting on the story mass of jth story and all the story above it. F I j of t is given by k equals j to n m k x double dot I k of t, which is equal to minus omega I square e omega I t summation k equals j to n of m k phi I k, where n is the number of story, m k is mass of the kth story, d I j of t is the relative displacement. That is very important. The relative displacement between jth and j minus 1th story. For ith mode of vibration, this can be expressed as d I j of t is x I j of t minus x I j minus 1 of t, which will be phi I j minus phi I j minus 1 e lambda I t d dot I j of t is given by x dot I j t minus x dot I j minus 1 t, which can be given by phi I j minus phi I j minus 1 of omega I e omega I t. In fact, this should be also omega I t. Let us call this equation as 4 and 5, where phi I j and omega I are eigenvector and eigenvalue of ith mode. Once the eigenvector and eigenvalue are measured for ith story, equation 1 can be formulated for jth story at each time interval. Using short data length, which is approximately equal to natural frequency of the building, equation 1 can be solved. One can repeat this procedure for other stories. To determine stiffness and mass parameter of each story. There are some salient points of this method. The first would be, this method assumes a known story mass. This method is applicable for lumped mass shear building model. Let us see the third method. Method to identify damage using element modal stiffness. In a linear undamped structure, ith modal stiffness is given by Ki is phi I transpose phi I bar transpose K phi, where phi I bar is the ith mode shape vector, K is the complete stiffness matrix of the entire structure. Now, combination of jth member to ith modal stiffness is given by Kij is phi bar I transpose Kj of phi I bar, where Kj is the jth member stiffness, jth member contribution to the total K. Now, fraction of modal energy of ith mode contributed by jth member is called modal sensitivity. Modal sensitivity is given by Fij is Kij by Ki. The above equation is valid for undamaged structure. This is modified for a damaged structure the modal sensitivity for a damaged structure is given by Fij star is Kij star by Ki star. Kij star is phi bar star transpose K star j phi bar star, and Ki star is phi bar I transpose K star phi bar I star. Kj is therefore expressed as Ej of Kj0 and Kj star is Ej star of k j 0, where E j and E j star represent material stiffness property related to undamaged and damaged state of the structure. K j 0 is assumed to be unchanged even after damage occurs. This method has a basic assumption. The basic assumption of this method is that modal sensitivity for ith mode and jth member remain unchanged before and after damage. Mathematically, f I j by f star I j, that is damaged and undamaged state, is k I j star k I by k I star k I j, which is unity. Now, the damage index beta j for the jth member is defined as beta j is E j by E star j. Substituting from the earlier equations, beta j can be expressed as I j star k I by I j k I star, which is phi bar I star transpose k j 0 phi bar star k I divided by phi bar I transpose k j phi bar I k I star. Now, further the damage index can also be approximated as below. Beta j is approximately equal to phi bar I star transpose k j naught phi bar I star plus summation of k equals 1 to n e phi bar transpose k j 0 phi bar star divided by phi I transpose k j 0 phi I plus k equals 1 to n e phi I transpose k j 0 phi I multiplied by k I by k star I. One can now obtain the normalized jamage indicator is given by Zj, which is beta j minus beta bar by sigma beta, where beta bar is the mean value of the damage index and sigma beta is the standard deviation of beta. Severity of damage can be estimated as E jar star is E j 1 plus d E j by E j, which will be E j 1 plus alpha j, where alpha j is gamma I j k I star by gamma I j star k I minus 1.